Good morning. This recording is for Pre-Algebra Chapter 9, Lesson 2, Angle Relationships and Parallel Lines. There are special pairs of angles that go together that form special situations. So the first one is adjacent angles, and they share a vertex and a side, but no points in their interior. So if I were to look at this angle AXB, which I would then call angle AXB, and notice how it's written. Notice how we name angles. We say a little angle sign, and then we start with one point. Then we talk about the vertex. The vertex is the point where the angle changes direction, and then the point that we have it named. So angle AXB is adjacent to angle BXC. And then again, that's BXC. And we say that they are adjacent because they're right next to each other. They share a ray, or sometimes a segment, or sometimes even a line. And in this case, it would be the line XB, or the ray XB, excuse me. And so they are adjacent because they're right next to each other and they share a line. All right, you see where the overlap of the orange and purple is? That's what they share, and that's why they're adjacent. So two angles that are adjacent share basically a leg of the angle. All right. So, what was that? Okay. So, another angle relationship is vertical angles. Angles are formed by two intersecting lines and are opposite each other. Vertical angles have the same measure. So, as you can see here, I have two lines. I have this line, I have that line, and they intersect each other, here, all right? And so there are four angles that are created by two intersecting lines. We have angle 1, angle 2, angle 3, and angle 4, right? So these angles are vertical, so vertical angles are ones that are across from each other. So in this case, angle 1 and 3 are across from each other. So that means that the angle of measure 1 and equals, or is congruent to, the measure of angle 3, which means, and notice how I wrote it down here, the measure of angle 1 is congruent, and that's the little congruent sign is an equal sign with the approximate bar over it, is congruent to the measure of angle 3. All right, and so that's how we write it out in just this little code form, basically writing it out with symbols. Again, the measure, which is a little m, the measure of angle, and this is just a little angle sign, of measure of angle 1 is congruent to measure of angle 3. And that's because they are vertical angles. They're across from each other. Anytime you have two lines intersect each other, you get two pairs of vertical angles. In this case, angle 1 and 3, and angle 2 and 4. Oops. So, what's going on here? All right, so that's it. So again, you could also have the measure of angle 2 is congruent to the measure of angle 4. All right, so congruent angles have the same measure, and the diagram above, angle 2 and 4 are congruent. We write this statement like this down here at the bottom. All right, and vertical angles are very important in determining the measure of angles, because if you know what the measure of angle 1 is, and you know that the measure of angle 2 makes it a straight line, which we're going to talk about in just a bit. That means that if you know angle 1, you can figure out angle 2. All right, so vertical lines are very important. All right, so just a reminder, these are all things you've probably learned in 6th grade math or even before. Acute angles measure less than 90 degrees. Right angles measure exactly 90 degrees, and actually, there we go. So again, acute angles measure less than 90 degrees. Right angles measure exactly 90 degrees. Obtuse angles are between 90 and 180. All right, so they're not exactly 90 and they're not exactly 180. They're somewhere in between. So basically, they could equal, well, really close to actually. They can't actually, because you can have actually a decimal degree. So I'm not going to actually write that. I'm just going to leave it as it is. All right, so 180-degree angle is a straight line, and we don't have a name for an angle larger than 180 degrees. Sorry. All right, So down here at the bottom, we have a straight line that has a measure of 180 degrees. We have an obtuse angle where the angle is between 90 and 180. We have an acute angle, which means the degree of the angle is less than 90 degrees. And we have a right angle where it is exactly 90 degrees. And as you can see here, we have this little box right there. That little box means that it's at a right angle. Whenever you see that little box inside of an angle, you can assume that angle is a right angle. All right, this little box meaning it's a right angle. All right, and there's your straight line. Okay, so pairs of angles that contain measures have special names. Certain measures. Okay, so if I put two angles together, and by putting those two angles together, I get a straight line. I have what's called supplementary angles. The two angles together equal a 180 degree or a straight line, which means that the two angles together are supplementary angles. All right? So if I have an angle and I add another angle and the two angles together give me a straight line, that red line right there, that means that they are still supplementary because the two form a right angle. Or excuse me, not a right angle, a straight line. Right angles next. All right, so complementary angles are two angles that when you put them together give you a 90-degree angle. All right, so if I take this unknown angle and I add another angle to it and they form a 90-degree angle, it means that the two angles together, again the original two angles, the blue angle and the purple angle together, form a complementary, together they're complementary because together they form a 90-degree angle. All right, so if the measure of angle 8 equals 20 degrees, find the measure of angle 5, 6, and 7. So this is actually going back to the vertical angle thing where we know some stuff about some stuff. Okay, so we know that angle 8 equals 20 degrees. Okay, so because angle 8 and angle 6 are vertical angles, they are going to be congruent. All right. So because the measure of angle 8 is congruent to the measure of angle 6, this is because they are vertical angles. We know that the measure of angle 8 is equal to the measure of angle 6, which means measure of angle 6 is 20 degrees. All right, because they're vertical angles, they're across from each other. So now we need to figure out what angle 5 and 7 are. Well, we know that when we put the measure of angle 8 and the measure of angle 5 together, we get a straight line. A straight line is formed, and that makes these intersect, and it's formed by the intersecting of these two lines, which means that the measure of angle 8 plus the measure of angle 5 is a straight line. And we know that a straight line is exactly 180 degrees, which also means that if we know the measure of angle 8, which is 20 degrees, and we add the measure of angle 5, we're going to get 180 degrees. So then if I subtract 20 on both sides, I'm going to get the measure of angle 5 on its own, which is 120 degrees. So therefore, we know the measure of angle 5. It's 120 degrees because, again, if I add up the measurement of this angle and this angle, I'm going to get this straight line. All right. Now, the measure of angle 7. Well, it's going to measure of angle 7, how we find it is the same way that we found 6. Vertical angles. We know that the measure of angle 5 is 120 degrees, and we know that measure of angle 5 and angle 7 are vertical angles because they're across from each other, right? And vertical angles are congruent, which means the measure of angle 5 should equal or be congruent to the measure of angle 7 because they're also vertical angles. So that means the measure of angle 5, which is 120 degrees, is the same as the measure of angle 7. So that means the measure of angle 7 is also 120 degrees. So then we have all of our answers because they wanted us to find the measures of angles 5, 6, and 7. Well, the measure of angle 5 is 120 degrees, the measure of angle 7 is 120 degrees, and the measure of angle 6 is 20 degrees. All right, moving on. All right, now, when you have one line that intersects two other lines, it has a special name, a transversal. So what is the one line that intersects two other lines in this little picture down here? Well, it's this one. That is the transversal, all right? Now, we have two things that come up when we have a transversal. And I need to pause this. Pause, play. Okay, I went a little too fast. Okay, So, two things can happen when we have a transversal: corresponding angles and alternate interior angles. Now, corresponding angles are angles that lie on the same side of the transversal and in corresponding positions. And corresponding means that they are in the same relative position. Okay, same relative position. So if we look here, I went ahead and I highlighted them. Oops, there we go. I highlighted them. And I highlighted them using this like really light blue color. And 1 and 5, they are corresponding angles. Notice how they're on the same side of the transversal as each other, and they're in the same relative position on the two lines, on the line L and the line M. All right, so notice how they're both on top of those two lines, L and M, and they're both on the same side of the transversal. They're both kind of on the left side of the transversal, and they're both on the top of L and M. That means they're corresponding angles. They're in the same relative position to the transversal and to the other two lines that the transversal intersects. Because by definition, a transversal isn't one line that goes through two other lines. All right, so other transversals we have are 3 and 7, 6 and 2, and 8 and 4. Okay, so those are all corresponding angles. Notice how they're kind of color-coded. They're color-coded because they are the ones that go together. All right, so if I said find me two corresponding angles, I would look at the same side of the transversal and then the same relative position. I'm looking at the top of the two lines L and M, and on the left side of the transversal when I say that 1 and 5 are corresponding angles. Okay, all right, so now let's talk about alternate interior angles. So I'm going to erase all that. An alternate interior means inside of the two transversals and one angle on each non-transversal. So we're looking at the inside of the two lines that are not the transversal. So since the two lines form an area between them, right? So like if I were to highlight it, this would be the area between the two lines, right? So I need to pick two angles that are inside the two lines that are on either side of the transversal and that are opposite each other, okay? So two angles that are opposite each other on either side of the transversal would be like 3 and 6. 3 and 6. And then another pair of alternate interior angles would be 4 and 5. So when you have a standard transversal with only two lines, you're only going to have two pairs of alternate interior angles, whereas if you have the same situation and are looking at corresponding angles, you're going to have 4 pairs instead of 2 pairs. Okay? Now really make sure you guys understand this terminology. It's going to be very important for you that you have it memorized, all right? All right, because I'm going to ask you to identify alternate interior angles, and if you don't know what an alternate interior angle is, you're not going to be able to identify them. All right, last slide. All right, if the two lines a transversal intersects are parallel, then we get very special situation going on here. We can say that that several of the angles, either corresponding or alternate interior angles, are congruent. So that relies on the fact that L and M are parallel. In the last example, L and M were not parallel, but in this one they are telling us they are. And they'll tell us they are by kind of writing it like this. L is parallel to M, and if you remember the vocabulary from the last video, you'll remember that these two parallel bars is a symbol that tells us that line L and line M are parallel. All right, so they want us to find corresponding angles, and then we're going to find alternate interior angles, and we're going to say that they are congruent. Okay, so if I'm going to go look for corresponding angles are on the same side of the transversal, and remember this is the transversal. They're on the same side of the transversal and in corresponding spots. So same place on the same side of the transversal. So congruent corresponding angles would be angle 1 and angle 3, angle 8 and angle 6, angle 4 and angle 2. But there's one more out there, isn't there? There is one more out there. What was it? Which was the one I missed? So we have 1 and 3, we have 4 and 2, we have 8 and 6, which means that I missed angle 7 is congruent to angle 5. All right. You guys ready? Let's go ahead and find congruent alternate interior angles. All right. So those would be 3 is congruent to angle 7. So angle 3 is congruent to angle 7. Let me go ahead and erase those real quick. Let me just erase it all. And you know that line's the transversal. It's still the transversal. That will never change. So we have angle 3 is congruent to angle 7. And we have angle 2 is congruent to angle 6. And remember, there's only 2 alternate interior angles when you only have one transversal, and there are 4 congruent angles when you're dealing with corresponding angles. All right, I'm done, guys. Bye.